Hey, Applied Pre-Cal, home stretch here. We've got a couple weeks left. We've got 2 more topics to cover. One of them is essentially its own unit, but we're going to combine it with our previous unit. It just seemed to work really well last semester. And that's called Systems of Linear Equations. We'll do our last unit on roots probably in about a week or 2. You'll have access to it either way, so we'll get there when we get there. Right now we're going to start with Systems of Linear Equations. A system is when there are multiple of something. So in this case, we're going to have multiple linear equations, and a system is when we have lots of them, and something happens when you have lots of them. Now, when you think of it, if I have a bunch of lines on some sort of grid or some sort of graph, the important points are where those lines cross. And that's what we're going to be looking for, is how we can figure that kind of stuff out. To get started, we're going to work with an example. Okay, so our example is that we have a school division that has buses. They have 2 different types, one that carries 12 passengers and one that carries 24. We also know that the total capacity is 780 people. We also know that there are 20 more small buses than there are large ones. My question to you would be, how many of each bus do we have? Okay, so on the surface it seems like a reasonable question, but then when you think about it, I don't have enough information about my school buses to figure out how many of each that I have. I do have some information that's given to me. Outlined in red is I know that there are 2 different types of buses. They have 12 passengers or 24 passengers, and the total of all those passengers is 780. And a separate piece of information they've given me is that there are 20 more small buses than there are large ones. So there is some information there. And one of the hardest parts of systems is figuring out what those hidden equations are. We should be able to draw equations from a systems problem, and later on, probably not in the grade 10 applied pre-cal section, but if you're in grade 11 or in the grade 12 course, you would have to find out if you have a system in the first place. That's just from reading the question. So let's start by maybe figuring out what those equations are. Alright, so I'm just standing off screen here so you can see the whole board. The first thing we have to do is establish what our variables are. Any type of equation needs to have some variables. We typically use x and y. You can use other letters if you wanted to instead. I'm going to use x and y because one of the examples I'll show you later on is using graphs, and I'm going to use Desmos, which uses x and y as well. I've seen people use S and L for this type of problem, S for small buses, L for large buses. I don't like using L for a variable, but that's a different topic. For this example, I'm using X for small buses, Y for large buses, and I'm stating that. That way, whoever's reading my content knows that, okay, I realize what your variables represent. Otherwise, who knows? So you have to say let, and then you have to establish what those variables are. If that's the case, then I can figure out my equations using those variables. So using the information that we've highlighted in red, we can figure out an equation that is 12x plus 24y equals 780. So that means that 12, which is how many passengers fit on the small buses, so 12 times x, plus 24 times y, how many passengers fit on the large buses, equals your maximum capacity, which in this case is 780. The other equation, this is a hard one to figure out, that's highlighted in blue. It says that there's 20 more small buses than there are large buses. So x is our small buses, and we figure out that if y is our large buses, adding 20 onto that will give us 20 more, and that would end up equaling x. So it's a tricky one. That's what we practice for. That's how we can figure out what these equations look like. At this point, I'm actually not going to solve it. I'm going to ask you to try some of this practice out. I realize that this video is posted with the additional section, so the parts that follow. Please try the practice out first, and then I'm going to show you multiple ways of figuring out a solution. We're going to start by graphing, and then I'm going to show you something called substitution, and then I'll show you something called elimination, and then I'll show you some complicated substitution problems and some complicated elimination problems. And hopefully you'll appreciate systems as much as I do. I think they're really cool once you actually understand how they work. And I realize I say that a lot, but take my word for it on this one. They're fantastic. Give it a try. Give some of the practice a shot. And I will see you in the next video where we start by solving using graphing.